In this lesson, we are going to talk about domain and range of relations that are continuous. In just a minute, we'll see what continuous means, but recall that the domain is a set of all input values or x values, and the range of a relation is a set of all output values or y values. So let's review. Actually, first let's look at number 1, which says, what is the difference between the two graphs? So the difference here is that in graph A, this is what we would consider to be discrete. Discrete means that we have distinct points, as you can see, 1, 2, 3, 4, 5 points. Where in graph B, we call this continuous. Now, if I ask you how many points there are, some of you might think 2. That's wrong. Actually, every single point, there's infinitely many points to make up a line, as you know. So in this case, even though we see these two endpoints, really, if they're connected, there's infinitely many points in between. So the point here is that it's continuous if every value is kind of connected, and you have, like in letter A, we just had 5 points. Here we have infinitely many, so it's not possible to list them all. So when it is discrete, just to recall for domain, you list those x values, which in the graph above, it looks like we have a -3, -1, 1, 3, and 5. So for the range, if I list the y values, it starts at -2 and then -1, 0, 1, and 2. I can't do that here, because if I try to list every single x value, it's not just -3, -2, -1, 0, 1, 2, 3, 4, 5. It's every single little fraction and decimal in between each of those integers as well. So we have to use what we call interval notation. Interval notation is where you put the first number, which here it's starting at -3, then a comma, and you put the last number. So for the domain here, it's the x values left to right, it's ending at a 5. And you then need to decide if you have a bracket or a parenthesis next to each of those endpoints. The rule is pretty simple. If it's an open circle, then you use parentheses. If it's a closed circle like we see here, then we'd use a bracket. The only other thing is if we see arrows, and if there's arrows to the right or to the left, we also use parentheses for that as well. So here's kind of a little chart. If you have arrows or open, use parentheses. And if you have a closed circle or a point, it's not open, then you use the brackets. So I put a bracket around the -3 and the 5. And this tells me that my domain, my x values are going from -3 to 5, and it includes everything in between there. Once again, how did I get the -3 and the 5? Well, this first point on the graph is at -3, -2. And this point on the graph is at 5, 2. And since I'm talking about domain, which is x values, I start at -3 and I end at 5. Now next is the range, so it helps that I wrote those ordered pairs out, because now I can see that the y values go from -2 to +2. Once again, we have closed circles here, so I put a bracket around each of those. Now, depending on the graph, there's lots of different things that can happen here. If we see arrows going left and right or up and down, then we're using infinity and negative infinity instead of other numbers. So we're doing a lot of examples. We have 8 more problems to practice this, so we see all types of things that could show up. All right, so in example 1A, domain and range. Actually, this should be pretty similar to what we had just seen. Domain, remember you're looking left to right, and you're looking at the x's. So the point to the left has an x value of -5, and all the way to the right, we have an x value of 3. So I put -5, comma 3 with brackets. The range is looking now at the y's, and that's going to be looking lowest to highest. So this lowest y is a 2, and this highest y is a 6. So I put 2, comma 6 in brackets. All right, I went kind of fast there because that was similar to our example above. All right, now in part B, it's not a straight segment connecting the two. However, it looks like, if I kind of do this, no part of the function goes to the left or above that first point, and no part of the function goes to the right or below that second point. So I've kind of realized that those endpoints will help me find the domain and range here, because there's no other parts of, well, what I'm trying to say is it's not like our function goes above it and then really we have a higher value up here. Okay, so whether it's straight or, curved like this doesn't really make a difference in this example. So for the domain, I'm looking left to right at the x values. The left point starts at -2, and all the way to the right it stops at 6. Now notice at the -2 it's open, so a parenthesis will go there, and at the 6 it's closed, so a bracket will go there. All right, down below, range got kind of cut off here, but to find the range, which is the y values, we look from lowest to highest. So at the lowest point, the y value is a 1. At the highest point, the y value is a 4. The lowest point is closed, so I put a bracket, and the highest point of a 4 is open, so I put a parenthesis. All right, we've got 6 more examples on the second page here. So, what I'm going to start doing is using the same color every single time for domain, and then I'll use a different color for the range. So for domain, let me just start over and I'll use orange, okay, every single time. So the domain is the x values. I'm looking left to right. When I look to the left here, there's an arrow going to the left, which would be to -infinity. All right, and then when I look at the point to the right, I'm looking at the x value. So this is our x-axis horizontally. That's a 4. Anytime you're dealing with positive or negative infinity, you're going to be using a parenthesis. That was in our chart on the first page. And then we have a closed circle for the 4, so a bracket would go there. Let's use purple for range. And for range, I'm looking lowest to highest. So when I look for the lowest point, once again, I have an arrow, and this time the arrow, I don't care about left or right. For range, I care about up and down. But since it's in the downward direction, that's also a -infinity. And then the highest point has a y value of 3. And that's closed, so I put a bracket there. All right. Now, when you're dealing with arrows for domain, which I'll use orange, domain, you care if the arrow's left or right. And left is -infinity and right is positive infinity. For the range, like I mentioned in this example, you don't care about left and right. You now care about up and down. Down is -infinity, up is positive infinity. So when there's an arrow like this, it's kind of like going left and down for domain and for range. It's not horizontal or vertical, though it is on a slant there, but in the left-right direction, it's going left. In the up-down direction, it's going down. All right, part D is similar. So let's start with domain. The x value is looking left to right. We start at -4. And to the right, it is an arrow going right to positive infinity. Infinity always has a parenthesis, and then the open circle also has a parenthesis. So that's what our domain would look like. Now for the range, I look at the lowest, which is an arrow downward, so -infinity, to the highest y, which is a 2. And that would be a parenthesis because it's an open circle. Let's move on to example E. This is interesting. It's, I don't know if it's exactly a circle. It looks more like an oval here. But that means that it does not pass the vertical line test, and it's not a function. But all we're asked for is the domain and range here. So for domain, I'm looking at the furthest point to the left, furthest point to the right. And what are those x values from left to right? So to the left, it looks like I start at -5, and to the right, I stop at 3. Now, is there open or closed circles? Well, an open circle is going to be pretty obvious that it's open. So if you don't see an open circle, then you assume it's closed. And if it's closed, we use brackets. For the range, I'm going to locate a lowest point of this picture and a highest point and list those y values from lowest to highest. So lowest looks like I'm starting at -6, and the highest looks like I'm stopping at a 3. Once again, we'd use brackets here. All right, part F. Now, I mentioned this up above, and now you'll see why. Here's a point, and here's a point. But are those the only values we're using for all of our x's and y's for domain and range? No, because when I look at domain left to right, yes, those 2 points are good. But if I look at the range lowest to highest, I actually need to use this point down here as well. So what I'm going to do on this problem, I think, is write out these three, I'll write out this point here. We have a -5, 4. I'll write out this point over here. We have a 5, 0. And down here, I'm going to say we have a -1/2. And then we have a -5. So it wasn't exactly at a nice point, but we'll just say it's close to -1/2, -5. All right, so in domain, which I've been doing in orange, I'm looking at the x's left to right. I start at -5. I stop at +5. You can look at what I highlighted in yellow. And they're both open circles, so those are both in parentheses. Now for the range, if all we consider is the 2 circles that we see, that does not go to the lowest y value. That's actually down here at the point that we kind of added in. So we have to make sure we start at -5 for the lowest y, and then it goes all the way up to +4. And the 4 is open, but the -5, the point down here, is going to be closed because it was just touching there. So that's a closed circle, and we do want to include that -5, and we use a bracket. All right, last 2 problems. I think these are similar to what we did in examples C and D. Why don't you actually hit pause and go ahead and try these, and then hit play to check and see how you did. All right, for part G, let's see how we did for domain. When I look at x values left to right, it looks like I'm going from -5 to infinity, and I'd have a bracket by the -5, parenthesis by the infinity. For the range, the y values lowest to highest, I start at -6 and I end at infinity. And that would also have a bracket and then parenthesis. So go ahead and check your answer to part G. And let's also see how we did on part H. Starting with domain left to right, I'm going from a -infinity to a 3. Both parentheses there because we have an arrow and an open circle. And for the y's, the range lowest to highest, I'm starting at a 1 and going up to infinity. And those are both parentheses because once again I have an open circle and an arrow. So when you see an arrow like this, you might think, is that positive or negative infinity? Well, notice in this case it's both. It is a negative infinity for the domain. When I look left to right, it's left. But it is a positive infinity for the range, because if I'm looking up and down, it's up. Okay? So you have a negative infinity for domain, but then a positive infinity for the range. So obviously there's only 4 situations with arrows. You know, it could be going positive and positive, it could be going negative and positive, it could be going negative and negative, or it could be going negative and positive again. So here in this quadrant, the arrow I drew is going left and up. So domain is negative, range is positive. For this one, the domain is positive, the range is negative. And then the other arrows would be the same, whether you're talking about domain or range. All right, that concludes our lesson on finding domain and range when we're dealing with graphs or relations that are continuous.